different techniques today, so we'll work on that. Yesterday we learned about how to look at a table and a graph. Not difficult to do. The biggest thing would be to make sure you get them typed in correctly. So what happens when you look at this? Well, the function is 2x squared plus 6x minus 5, U-shaped graph, right? Parabola. It's continuous everywhere. So direct substitution, we're just going to take the 1 and plug it in. So 1 squared is 1 times 2 is 2 plus 6 minus 5. 8 minus 5 is 3. So that will be your limit. I don't know, what did I do?
4.
No, can't you do it, right? Can't you use
Alright, what happens when you plug in the 2? Now this is a rational expression, so like think back to 2627. You're going to have problems if you run into vertical asymptotes on the graph. But if you look at the bottom of that graph, the bottom is x squared plus 2, right? So the bottom is a U-shaped graph that would be shifted up. Can you make the bottom ever equal to 0?
No.
It'll never be equal to 0. So we don't have to worry about anything there. So we're going to put a 2 up top. Minus 2 minus 1 all over 2 squared plus 2. So you have 4 minus 3, which would be 1. And on the bottom, it looks like 4 plus 2, which is 6, right?
Yeah.
So this is what I'm referring to as direct substitution. If you take that number and you plug it in and it's working, great. That'd be awesome. However, sometimes work. Sometimes we get this 0 over 0. So what happens when I plug in 3? What's 3 squared minus 9 over 3 minus 3? 0 over 0. This does not tell us anything except that the direct substitution technique didn't work. So now you have to do something different. You can go to the graphing calculator and look at a table. You can look at the graph itself. In this case, the rule, what they're talking about up here in the box, is what we did in 2627. So we're going to rewrite it. What is the limit as x approaches 3? We're going to do x minus 3 over x plus 3. Or excuse me, x minus 3, x plus 3 on top.
9.
X minus 3 on the bottom. What did we do in 2627? The idea is that x minus 3 is not a vertical asymptote, it's a hole in the graph. So the graph will look continuous except for right at that particular positive 3 value. So what we're going to do is get rid of the x minus 3, and we're really going to do what's the limit as x approaches 3 of the x plus 3 that's left over. So now, what happens when I do my direct substitution? Now I put the 3 in and I get 6. Put the 3 in. For x, 3 plus 3.
Oh, I thought you were solving.
So, any questions on that one? Alright, the next one, you have x minus 1, x cubed minus 1. Some of you may have memorized the difference of cubes, it's called. But knowing what we're doing, it would be really nice if the x minus 1 factor was inside the x cubed minus 1. Because what happens right now when you plug in the 1? Get 0 over 0. That doesn't tell me that the limit doesn't exist. It just says do something different. So some of you might be able to do, we want to see if x cubed minus 1 has the x minus 1 factor in it. So x cubed minus 1, you could do polynomial division, or I can set up 1x cubed, 0x squared, 0x, constant of -1, and I can divide by 1, do my synthetic division. Because when I do x minus 1, I put a positive 1 out there, and x cubed plus 0x squared plus 0x. Remember, you just use a coefficient for synthetic division. So you can do it either way. I'm not actually doing the division that's in the problem. I'm seeing if I can find what's left over. So if the 1 drops through, 1 times 1 is 1, 0 and 1 is 1, 1 times 1 is 1, 0 and 1 is 1, 1 times 1 is 1, and it worked. So what this tells me is that x minus 1 is a factor of that x cubed on the bottom. And this right here, remember, constant x squared. So x squared plus x plus 1. So what are we going to do? There's an x minus 1 factor on top and on the bottom of 1 over x squared plus x plus 1. Now my direct substitution will work. What happens when you put a 1 in there and you put the 1 in there? 1 squared is 1 plus 1 plus 1. So I get a limit of 1/3. So what's happening is when you start the problem, you put the number in, because that's the easiest way to find it. You get a 0 over 0. Does not say anything about not working. It says do something different.